All right, friends. So, Friday, goofy day. We made it work. So, 3 quizzes left. 3 quizzes left for the semester. 3 quizzes left, including one this coming Friday.
Don't we have one like?
Honestly, I feel like that one's gonna be
3 quizzes left, including what this Friday holds.
so easy. So easy.
Who drew Kermit? That's really
It
good.
looks really good though.
So,
Yo, have a good day, guys. It's
now I canceled the quiz. I took one out.
Oh, nice. That's good.
Yeah,
Because I need to actually study for this one, so I can like pass.
actually study for this one. Okay.
what are you gonna do? What are you doing with
Alright, nerd.
What are you doing? Are you crying?
All right. Now, with that said, 3 quizzes left, 4 weeks left. Yowzers. And a couple of youths
Grandpa coming in tomorrow morning to make up another one.
owe me some stuff.
Bless you.
That's a little. Just a couple assignments.
He was showing me all
It's
this
just
stuff that
us.
Cooper's got.
Yeah, it's like 4.
He's got stuff still from his freshman year.
Cooper?
Yeah.
Yeah.
Cooper.
All right.
Yeah. Awesome.
I think we're gonna move slow.
I'll ask her for you. Yay.
All right.
Good job.
So, we have been dealing with asymptotes galore, yes?
Dupes?
Yeah.
Dupes. Necklaces?
So, let's even dement our asymptotes even more with my hiccups. All right. So there's times that when we have these rational functions. Now, before I start, we have a rational functions capstone that needs to be taken. You got to come in on your own. You're ready for it?
Can I come in tomorrow morning?
Yes.
Before your meeting?
You
have a meeting?
I don't have a meeting tomorrow. It got canceled. Yay.
You.
So, I think I've had 9 or 10 people take it and did just fine on it. Let's get it done. And rational functions.
Like
Is it gonna be like?
Yes.
Or factoring?
Easier than this.
Will it be
Like
like
the
everyone in school?
Easier.
The next.
Is there a practice one?
Yes, there's a practice one in Schoology. This one, basically, you have to realize where the numerator is equal to 0 is where you would have roots. Where the denominator is equal to 0, you have asymptotes. How do you graph it? How do you know how it shifts right or left? If it's grouped, it shifts right or left. If you have an addition or subtraction sign, it shifts up or down. I mean, that's as basic as it comes. I think this last rational function capstone is the easiest of the 3. So.
Are you still doing the thing where if you get like 7 out of 10, you get 20 out of 20?
Yep.
Nice.
Wait, so are you adding, like, you know how you said like if you get like an 8, it's like more extra credit? Are you adding that to at the end of the
It'll
semester?
come at the end.
Okay.
So if you're sitting at that 89.2, you have an A minus, not a B plus.
I won't have you either.
All right. So if you're sitting at that 49.2,
No, you guys are smart.
you gonna be all right?
No, I just choked on my coffee.
Atta girl. All right. So let's go through this. Let's go through. Should be good to go. So still, what you have in the numerator and the denominator, you deals with zeros. The zeros come with the numerator.
Which would be the vertical? I remember that there's a certain way.
All right. Ready? Okay. If P at X, the top, and Q at X, the bottom, have no common factors other than 1, then the graph of the relation of the function is that. It has several characteristics. The roots of the graph are real zeros of P at X. That means whatever the numerator equals out to 0, as long as it doesn't have any binomials in common with the denominator, it will cross the x-axis where the numerator is equal to 0. Let's see if we can clear that up. Okay, there's way more information up there than I ever want to see. Steps to graph rational function in these forms. Find the domain, set the denominator equal to 0, solve for x. The domain is all real numbers except for that value. Okay, today we're actually going to see multiple vertical asymptotes. Find the vertical asymptote by setting the denominator equal to 0 and solving for x. If x is not a real number, then you don't have vertical asymptotes. And then horizontal asymptotes. If the degree of the numerator is, so n is the degree of the numerator and m is the degree of the denominator. So if n is less than m, y equals 0 is our horizontal asymptote. If n is equal to m, you take the lead coefficient of your highest exponents. Okay, so that'd be a over b. And then if n is greater than m, we don't have a horizontal asymptote. So if I have a higher degree on top than on bottom. Okay, and that's actually going to go to something that we call oblique asymptotes or end behavior asymptotes or things like that. Find the x-intercepts or roots. So we're just going to set, first off, you factor everything on top and on bottom. If anything cancels out, that's going to run into something called a hole. We'll see what a hole looks like tomorrow. Find the y-intercept, so you plug 0 in for x. And then find a few more points to the right or left of the vertical asymptote. So that's just kind of telling you how to find the direction of it. Okay, so just a note, I have the quiz on this Friday for this stuff. And there was a third, so that's the third quiz. The second quiz never made it to the printing press. Got it?
Wait, the one that I came in and took?
Yeah, but it was good for you to take it. No, there was one that was planned for today.
Oh.
It never made it to the
I
printing
thought
press.
you were saying that.
Meaning
The
I
one that
canceled
came in
it.
and took, like, didn't even matter to me.
You what? No, I wouldn't do that to you.
Right, thank God.
I do it to other people, but not you.
How'd I do?
A++.
Yep.
All right, so let's take a look at this one. Is the degree on top equal to the degree on bottom?
Yes.
Okay, everyone's okay with that?
Yep.
So the degree on top, this is equal to this, so I'm going to go 1 over 2. So I have a horizontal asymptote at 1/2. Is that okay so far? Anyone stuck on that? All right, I want to erase this so we can see that again. All right, so now, vertical asymptote. What can I factor out of the denominator? Does the denominator factor to anything? X times what? Guys, come on. Let's get this done. So that's what my denominator will factor down to. You with me? How many solutions does that incorporate then? How many solutions could that be? 2. One of them is what? 0. So I get x equals 0 because of this. And then I get x equals -1/2. Are we okay? Okay. So we have 2 vertical asymptotes on this problem. So let's draw our vertical asymptotes in. So I have one here. And I have -1/2. Ew, jeez. Yowzers. I don't know if I don't like this. I'm going to get a different graph. I'm going to go erase this. Grab that. Trash that. Math. Graph. Cartesian. Blow it up. That's good enough. All right. All right, so vertical asymptotes. 0. So this is a different graph than you have on yours, and I apologize. And then I think I could squeeze half in there. Is that okay? Horizontal asymptote is at positive half. Okay, so let's figure out X-intercept. X-intercept means I'm going to take x squared minus 9, set it equal to 0. So I'm going to get x equals plus or minus 3. Does everyone agree with the math? Add 9 to both sides, take the square root. So I get a positive and a negative 3. Thank goodness it fits on my graph. Is that okay so far? And then the y-intercept. How do I find the y-intercept? Plug 0 in for what? X. If I want to find the y-intercept, I plug 0 in. So if I plug 0 in here, 0 in here, 0 here, uh-oh. What happens? If I plug 0 in all the way through, it's undefined. So does it have a y-intercept?
No.
This one doesn't. So I plug 0 in for everything, I get an undefined term. So let's list our domain. Our domain goes along with here. So my domain goes from negative infinity to negative half, from negative half to 0, and from 0 to infinity. Okay? All right, so do we already have two kind of points that we have available up here? Let's try and graph this the best we can. Let's use a fancy dancy color, orange. So here is one. Here's another. Is that okay so far? Okay, how do I know it's there? Well, basically this breaks into 1, 2, 3, 4, 5, 6 quadrants. I have a point in this one and this one. And then this one becomes squeezed in the middle, like that. Good luck squeezing it on yours with that one from negative 10 to positive 10. Okay, that's not too bad. Okay, additional points. Should we really go and try and plug additional points in? Again, you're just dealing with really minute, small fractions.
Do we have to do additional points?
You do? Yes. Everyone else knows. All right. Can I move on?
Yes, sir.
Yay. Okay, so same idea. Vertical asymptotes. So does the first off, let's go to the horizontal asymptotes. The degree on top is 1, the degree on bottom is 2. So the degree on top is less than the degree on bottom. So my horizontal asymptote has to be y equals 0. Is that okay? Okay, so let's draw that in. And we saw the other day, sometimes that horizontal asymptote is crossed. But we'll see what happens as we progress. All right, so let's factor this bottom. I know that I have x minus 2, and x plus 6. So I have a vertical asymptote at 2, and I have a vertical asymptote at negative 6. So this one's a little nicer for us to graph. Negative 6, positive 2. Bless you. Can everyone see how that graph is now divided into 6 regions?
Yes.
Make sense? All right, so where will it cross our x-axis? Take the numerator, set it equal to 0. Wait, it crosses the x-axis, but I have a horizontal asymptote right there. Is this legal? Sure. Let's figure out where it crosses the y-intercept. Y-intercept, I'm going to plug 0 in for my x values. I've changed colors. Plug 0 in, so I get 3 over negative 12. So that's what? 0, negative 1/4? All right. Looks like this. Why does this one look like this and not make the bounce? Because it crosses the x-axis. Okay. I'm not done with this yet, but I think on this one I'll use some test points though. So I domain from negative infinity to negative 6, from negative 6 to to 2, and from 2 to infinity. Now let's just, for sake of goodness, plug in some extra values. Let's see what we get. I'm using a calculator because I can't do it unless you get on your phone. Thanks for paying attention.
Mr. Sherman, please cancel that quiz. I haven't done anything for the whole semester.
That's the second period he's got called out by his teacher.
It happened first period too?
Second period, I was
No.
A second?
Nothing happened. That's fine.
Yeah, no, he got called out for ditching.
I almost wasn't going to say
No,
anything
no,
because you
yeah,
got a
I was
Michigan
sick.
hat on. If it was
No, I
Ohio
was-
State, I would have been ripping on you all day long. But
I would never do
That's
such
what
a
we
thing to you.
I'm glad you wouldn't. All right, so I want to just, for sake of doing these problems, I want to do, give me a better color. I want to just try and plug some points in. So I'm going to take negative 4, see what happens. If I take negative 4 and plug it in top, I'm going to get negative 1. And I get, what was that, 16, minus 16. So that gives me 1/12. So negative 4 comma 1/12. Yeah, we're fine. And then I want to take negative 2. I'm going to just go on the other side of this, see what happens. If I take negative 2 and plug it in, because it's on the right side of where it crosses the x-axis, I'm going to get 1 over. If I take negative 2, plug it in, I get 4 minus 8, so negative 4. So negative 1/16. Yep. So that definitely works. That's why that region looks like that. Okay? Now, I think a point to pick in is take negative 7 just to see, to verify. And once you see the pattern, I don't think you have to do it anymore. So negative, so that was negative 1/16. Take negative 7, plug it in, so that gives me what? Negative 4, and that's going to be 49 minus 28 minus 12. So negative 4/9. Is that right? Yep. So negative 7 4/9. So this one's going to look like this. And then, so notice this. This goes down. And then this becomes this asymptote coming down this way. This is going to dictate what's going on here. They're not going to approach each other because they're not even roots in the denominator. So if this did this here, so notice it's going to negative infinity. This is coming from positive infinity. So this one here is going to do this. So I went like that, one opposite, one opposite. Kind of a yucky looking graph. And I would say definitely, you're gonna have to use a calculator on this.
I agree.
Okay?
Is the whole test going to be calculated?
For you, Sam, no. I'm gonna tie one hand behind your back too. So Sam, do me a favor. Tell me what this equation is when I log into Desmos. Is that cool?
Sure.
Thanks, man. Y equals what? What's on top?
X plus
You got
3.
notes there.
X plus 3.
X plus 3 over x squared plus 4x minus 12.
Plus 4x. Plus 4x
Minus 12.
minus 12. Does that
Yeah,
look kind of similar to my graph? I mean, it's a little neater, yes?
Yeah.
I think yours looks better.
Thanks.
it's prettier, it's more colorful.
So,
Sure.
the thing to note on this is, remember this point here? This is crossing our asymptote. Why did it cross the asymptote? Because there's one value that does exist. Okay? But again, if you don't have a graphing calculator, you'll have to grab the Chromebook and use Desmos on it, which is fine. I mean, I think Desmos works a little bit easier than the graphing calculator.
Yeah.
You don't get to zoom in.
Huh?
You look for the zoom.
Yeah, it just adjusts for you real easily. All right. Did we answer everything here? I like it. Am I done with the notes? No?
You got 2 more slides.
All right. So degree on top is equal to degree on bottom, yes? So my lead coefficients are 1 over 1, so my horizontal asymptote is y equals 1. Vertical asymptotes, x equals 4, x equals negative 4. So it's where the denominator is equal to 0. So positive 4, negative 4. You guys talking ice cream?
Yeah, you want some?
Yeah, always. Where's our X-Intercept? So the X-Intercept is where if I take the numerator and solve it, so that's x plus 2, x plus 5. So if I set those equal to 0, I get negative 2 comma 0 and negative 5 comma 0. Agree? Negative 5. Okay. Y-intercept, I'm going to plug, take a nice purple. Y-intercept, I'm going to plug 0 in for my x's, so I'm going to get 10 over negative 16, which is negative 5/8. 0, negative 5/8. Right about right there. Okay, so the domain, negative infinity to my first vertical asymptote, my first vertical asymptote to my second vertical asymptote, my second asymptote to forever. All right. Is it going to cross our x-axis? Or it's crossing our x-axis, isn't it? It's going to cross the orange line. I don't know. Let's find out. So let's pick a. That's pretty vibrant. I like that one. All right. So let's pick negative 3 so it happens. Take negative 3, plug it in. That gives me 9 minus 21 plus 10. That's a 10. So that's negative 2 over 7. So that's negative 7, so 2/7. So negative 3 is at positive 2/7. Okay. Let's take, I can't do negative 4 because that's 0. So let's take positive 1, see what happens. I'm just trying to figure out what's going to go there. So I get 1 plus 7, that's 8. So I get 18 over negative 16, which is negative 9/8. Crud. Is anyone opposed if I graph this on the graphing calculator? I think it's going to look like this. I think. This is my thought. I'm going to grab my sheet just so I don't have to rely on Sam.
It's
Last page, right?
Yeah.
Cool. All right, so I think it looks like that. Do we have a second on that? X squared plus 7x plus 10 divided by
Presbyterians.
squared. Come on, baby. Does that look like my graph?
Yeah.
The one is a little higher up, I guess.
Yeah.
Well,
And it's what?
Oh yeah, it does.
close enough.
Yeah.
Yeah.
Not too bad for hand-drawn versus the real. So again, we get a crossing we have it crossing this asymptote. We said the asymptote here was at positive 1. So you have to actually zoom in to see what it's crossing right here. Cool. Can you handle the last one on your own? Or hang on, what is that last one factor to? X plus 2, x plus 3. Ooh, I gotta do that last one, sorry. Alright, let's factor the top. X plus 2, x plus 3, agree? What is the bottom factor to? X minus 2, x minus 1? Okay, this is actually going to become key for tomorrow. Are any of those on top and bottom able to cancel out? No. So that's actually going to create something called a hole for us tomorrow, and we'll see what a hole looks like versus an asymptote. I know it sounds so exciting, but all right. So vertical asymptotes, we have x equals 2 and x equals 1. Jeez. This isn't going to be fun. Okay. Horizontal asymptote, degree on top and degree on bottom are the same. Lead coefficients are 1, so y equals 1. X-Intercept. Oh. X-Intercept, solve the top where it's 0. So I get this is going to give me negative 2, 0 and negative 3, 0. Negative 2, 0. Negative 3, 0. Dude! The Y-intercept plugs 0 in for your x's.
Oh, so it's going to be in between those small lines.
0, 3. There. Jeez Louise. Our domain. Negative infinity to negative 1. Negative 1 to negative, or to positive 1. To positive 2. And from 2 to infinity. And who am I faking if I say I'm going to graph that on my own? Alright. Desmos, my hero. I don't know what I used to do before graphing calculators in the system, I thought. X squared plus 5x plus 6. Divided by.
Did you guys have those things that were like the wooden things that had all the different colored like circles on them that you moved instead of
I didn't have an abacus, no.
abacus?
I
learned
had
how
my
to count.
fingers.
On my own.
What was the point of
It teaches you to count.
Yeah.
Yowzers.
I think it's supposed to teach you how to multiply and stuff. I don't know.
Alright, so I thought I was going to be wrong about this, but take a look. Exciting moment here.
Whoa.
See, it dips below at negative 3, like we said, and at 2. We had that here and here. Fascinating stuff. Let's see. Come back out. Ooh, man. I want something to happen in between, but it's not happening in between. It's like we have this no man's land in between. Alright, so fascinating stuff. Here we go. Does this.
no, doesn't it go?
Oh, I don't know. Uh-oh. Oh, it goes up. Oh, yeah. Oh, shoot. Undo, undo, undo. So does this. Like that?
Yeah.
Something like that, I don't know.
Yeah.
And then what does the other one do?
It goes up as well.
And then it does this. And what happens here?
No.
It's got to be no man's land. I think that something should exist in between those.
How is it crossing the horizontal asymptote?
It's just one of those strange things because we have the multiple. It's even powers.
Okay.
And I'm just curious. Oh my gosh, that's 1.5. 1.5.
This is
Talk amongst yourselves as I work this one out.
You mean going?
1.5
Started.
I'm not paying for
plus 2.
Mhm.
I mean, is it time like
Plus 3.
if you think about it? Is it time just to learn the concept?
And I get 5 squared minus 3 times 1.5
No other animals
plus 2.
Yeesh. I'm gonna wake up
15
at
is
6.
5
I'm 105.
divided by negative 105.
I guess I don't. They just don't have a lot.
All right, here's the amazing thing. At 1.5, which is in between these, we have the graph at negative 63. So why can't we see this on our graph? Because we didn't zoom out enough.
I don't read it.
Wait. Oh my gosh.
Wait, what the hell?
So
How did I get there?
So
I was like, I don't want to see any of these.
So the strange thing about that one is way down here it does this, where this point right here is 1.5 comma negative 63. I realize my graph goes to negative 10, but you have this little skinny thing. How would you know that? I mean, honestly, how would you ever hand graph that and remotely make it possible? I say you can't. So, but it does, the graph itself does exist in between those two vertical asymptotes. And that's all I got for you today. No applause, just throw money this time. So what do you guys want? Miwa, even or odd? Even? Let's take a look, make sure. 11 HI. 11I evens gives you 1, 2, 3, 4 problems. I like it.
Oh, that's what I like.
All right, so that it's going to be worksheet 11I evens. And I would probably say, great if you're using your graphing calculator, but being that Desmos is a little more user-friendly, maybe you could do those 4 problems on Desmos and take a look at it. Put this back in the...
How do you graph it? Just like
On your graphing calculator?
do like number 20.
Y equals?
Well, y equals, but how do you do the over? Because like I just did the divide.
So you're going to go, put this in parentheses, I'm going to go x plus 3.
Okay, were you there?
And then x squared plus 4x minus 12 close parentheses. And so sometimes you have to have double open and double close. Yeah. And then graph. So the hard thing about this is like if we go zoom standard, we see that. I forgot which problem this was. Was this the last, or this was the last one? So it doesn't necessarily show it all, but that's, so this is where it's passed in here. That's where Desmos is easier because you just have plus or minus on it. What's up, dear? H. I never collected it. I never collected it. And you did it.
This is legit me.
What do you say? I'll take a look at it tomorrow. All right, so just, and what was that, evens on that, on H, or odds? All right, so just so you know, worksheet 11H, it was the odds, evens. What is it? Evens. Being we had a goofed up week, guys and girls, if you turn this one in tomorrow, I will make this as an extra credit in the homework.
Wait,
Huh?
actually do it. Wait, 11H?
11H, if you haven't done, because we got all goofy last week,
Let's go.
So if 11H, you get it done, the evens, turn that in tomorrow. I'll make sure it counts as an extra credit homework. I gotta be honest. An extra credit homework won't move too many grades too much.
But it's
Well, you know, the kid who has a 7%, he moves up to like an 11%. The kid who has a 94% still goes in and still has a 94%. So there's not that much movement.
Would it your grade up like point
If you have a 7%.
like 1%?
It has to do with how high your grade is. If your grade's really high, very little movement. The lower your grade, the more movement.
Okay.
So that means it's one of those where the kid with the 11% says, "So I got a chance."
So if it's
Yeah.
like
Sure, Drew. Go for it.
Yeah, but big on